Hi friends, this is a simple buck converter circuit. A buck converter is used to step down a higher voltage to a lower voltage using a switch, an inductor, and a capacitor. In the circuit, the input is a 5-volt supply and a 1 kilohertz switching signal turns the transistor on and off very quickly. When the switch is on, current flows into the inductor. When the switch turns off, the inductor keeps releasing its stored energy. Because of this constant switching, the inductor and capacitor work together to produce a lower and smoother output voltage. The inductor is very important in a buck converter. When the switch is on, the inductor stores energy like a magnetic spring. When the switch turns off, the inductor does not allow the current to drop suddenly, so it releases that stored energy into the circuit. This makes the voltage after the inductor more stable. In the simulation, the switching happens very fast at 1,000 times per second, so the inductor keeps charging and discharging smoothly. This is why the waveform after the inductor does not look like sharp pulses. After the inductor, the capacitor filters the voltage even further. The capacitor charges when the voltage rises and discharges slowly when it falls. This action removes the fast ripples produced by switching. The resistor at the end acts like a load where power is delivered. The voltage across this resistor becomes output voltage. In the simulation, the output is around 2.4 volts. This shows that the buck converter is working correctly because the output is less than the input. On the graph, the orange signal shows the switching pulses, which go from 0 to 10 volts repeatedly. The blue signal shows the output, which becomes smooth and stays around 2 to 3 volts. This is exactly how a real buck converter behaves. The switching creates pulses, the inductor smooths the current, and the capacitor cleans the voltage. Together, they reduce the 5-volt input to a lower stable value. This makes buck converters very